Problem 140, Quantum Mechanics. The question is, a quantum particle in one-dimensional infinite potential well with boundaries at 0 and a is perturbed by adding h prime is equal to epsilon delta x minus a by 2 to the initial Hamiltonian. The correction to the energies of the ground and the first excited state to first order in E are respectively. Here we have to find out the first order correction in ground state energy and the first order correction in first excited state energy. The perturbation is added to the particle in one-dimensional infinite potential well. So the first order correction in ground state energy become integral 0 to a root of 2 by a sin pi x by a. The perturbation is epsilon delta x minus a by 2, then again root of 2 by a sin pi x by a dx. And this is equal to 2 times epsilon by a integral 0 to a delta x minus a by 2 sin square pi x by a dx. We have integral over all space delta x minus a f of x dx is equal to f of a. Therefore, our integral become sin square pi by a into, instead of x we have a by 2. That is sin square pi by a into a by 2. Therefore, the first order correction in ground state energy E01, that is equal to 2 epsilon by a into, we can write the integral as sin pi by 2 whole square. That is, the first order correction in ground state energy is 2 epsilon by a. Now let us find out the first order correction in first excited state energy. For the first excited state energy, the wave function is root of 2 by a sin 2 pi x by a. Therefore, E11 that is equal to integral 0 to a root of 2 by a sin 2 pi x by a epsilon delta x minus a by 2 root of 2 by a sin 2 pi x by a dx. That is E11 is equal to 2 by a epsilon. Now integral 0 to a delta x minus a by 2 sin square 2 pi x by a dx. Now the value of the integral is sin square 2 pi by a into a by 2. Therefore, the first order correction in first excited state energy E11 is 2 epsilon by a sin pi whole square and the value is 0. That is, the first order correction in first excited state energy is 0. Therefore, option B is the right option.